Imagine stepping outside and realizing that the very air around you isn't the biggest danger you face. It's the invisible storm of energy blasting through your body every single second. And the craziest part, most of us have never even thought about it. That's right, space radiation. It's like the universe's hidden danger, lurking out there, waiting for anyone who dares to leave Earth's protective bubble. NASA talks about it sometimes, but what they don't usually share are the little details, the ones that make you stop and think, wait, how do astronauts even survive out there? Now before you panic and start wrapping yourself in aluminum foil, let's take a step back. Because this isn't just a space problem. This is actually one of the biggest puzzles, holding us back from becoming a true spacefaring species. And if you've ever dreamed of seeing people live on Mars, or even asked yourself if humanity could ever go beyond, this is the question that decides it all. See, rockets, spaceships, even food supplies. Those are technical challenges. We've solved them before, and we'll solve them again. But radiation, that's like playing chess against the universe. The stakes are your cells, your DNA, your health. And if we lose, humanity might never step beyond our little neighborhood in space. Sounds dramatic, right? But that's exactly why this matters to you. Because one day, maybe in your lifetime, maybe in your kid's lifetime, humans will be packing bags to head off to Mars, or maybe even deeper. And the truth is, space radiation isn't like bad weather you can just wait out. It's everywhere, it's silent, it's invisible, and it's dangerous in ways you don't expect. NASA knows this. They've studied it for decades, but they don't exactly tell the whole story in those glossy press releases. And that's what we're diving into today. So let's start with something super relatable. Have you ever gotten a sunburn? That hot, burning, itchy pain when you stayed outside just a little too long. That's radiation too. Just regular old ultraviolet light from the sun, messing with your skin cells. Now imagine that sunburn wasn't just on the surface, but deep in your tissues, even in your bones. Imagine the same invisible energy, not only burning you, but rewriting the instructions in your DNA, like some cosmic hacker breaking into your code. That's what astronauts are up against every second they're in deep space. And here's where it gets really wild. On Earth, we're shielded. We've got our atmosphere, this thick blanket of gases that absorbs a huge chunk of the dangerous stuff before it ever touches us. Then we've got Earth's magnetic field, like a giant invisible force field, pushing most of the charged particles away. You don't see it, you don't feel it, but without it, you wouldn't last very long. Seriously. That's why astronauts on the International Space Station are still relatively safe. They're floating above the atmosphere, but they're still tucked inside Earth's magnetic bubble. But the moment you leave that bubble, heading to the Moon or Mars, you're walking out into the cosmic firing range. Now let me ask you a question. When you think about space travel, what do you imagine as the biggest danger? Explosions, running out of oxygen, maybe a stray asteroid smashing into the ship. Those are real dangers, sure, but they're quick, dramatic, obvious. Radiation isn't like that. Radiation is the slow, sneaky danger. The one that doesn't announce itself with flashing lights or loud noises. It builds up, molecule by molecule, day after day, until, bam, your cells can't take it anymore. And you might be wondering, okay, but if it's so dangerous, how did the Apollo astronauts survive going to the Moon? Good question, because technically, they were outside Earth's shield, right? Here's the thing, timing and luck played a huge role. The Apollo missions were short, a few days to get there, a few days back, and radiation isn't constant. It comes in bursts, like cosmic weather. If a big solar storm had gone off while the astronauts were halfway to the Moon, things could have ended very differently. And guess what? That's not a risk you can just shrug off. when planning long-term missions. Picture this. You're on a trip to Mars. It's not a weekend getaway. It's a 7-month journey just to get there. Then you've got to stay on the surface, wait for the planets to align again, and then take another 7-month ride home. That's years of constant radiation exposure. Your body isn't built for that, and the side effects? They're brutal. Higher risks of cancer, cataracts in your eyes, even brain damage. NASA has quietly admitted this in their studies. Long-term exposure might impair astronauts' memory, mood, even decision-making. Imagine being on Mars and your mind isn't as sharp as it used to be. That's not just dangerous, it's terrifying. But here's where I want you to pause and think about something. We're so used to seeing astronauts as these invincible heroes, in shiny white suits, bouncing around on the moon, or floating weightlessly in space. But deep down, they're just like us. Their bodies are made of the same fragile cells, the same DNA. Space doesn't care about bravery. Space doesn't care about your training. Radiation will break you down all the same, and yet they still go. That to me is mind-blowing. So why doesn't NASA talk about this more openly? Well, think about it. If you're trying to inspire the next generation, convince the public to support space exploration, you don't exactly want to start with, by the way, the universe is trying to microwave us alive. It's not a great poster slogan. Instead, they focus on the adventure, the discovery, the excitement. And I get it, we need that optimism. But if we really want to become a spacefaring species, we have to face this invisible enemy head-on. And that's exactly what we're going to explore next. Because in the next part, I'm going to tell you about the weird, creative, almost sci-fi ways scientists are trying to protect astronauts. We're talking spacecraft that double as radiation shields, drugs that could work like space sunscreen, and even wild ideas like living underground on Mars. And trust me, some of these ideas sound so crazy, you'll wonder if NASA has been watching too much science fiction. But before we get there, think about this. Next time you step outside and feel the sun on your skin, remember, you're already living in a protective bubble. Without it, that simple warmth could be deadly. And the real question is, how do we take that bubble with us, wherever we go in the universe? That's the puzzle, and the answer might just decide the future of humanity. So we left off with this huge question. How do we take our protective bubble with us into deep space? Because stepping out of Earth's shield is like walking outside during a lightning storm, wearing a giant metal suit. You're just begging to get zapped. And yet, scientists, engineers, and astronauts are all working on this exact problem. And let me tell you, some of their solutions sound like science fiction that somehow stumbled into reality. Let's start with the most obvious fix: shields. If radiation is hitting you, block it, right? Sounds simple, except it's not. Space radiation isn't like rain that you can just hold an umbrella against. It's high-energy particles, tiny bullets moving at nearly the speed of light. And when these little cosmic bullets smash into matter, they don't just stop. Sometimes they break apart and create even more dangerous particles. Imagine swatting a mosquito, and instead of it dying, it explodes into 10 more mosquitoes, all just as annoying. That's what shielding in space can feel like. So what do scientists do? They get creative. One idea is to build spacecraft out of special materials that can slow down these particles without making things worse. Strangely enough, one of the best candidates isn't some futuristic metal or exotic crystal, it's plastic. Yep, good old hydrogen-rich plastic. Turns out, hydrogen atoms are really good at absorbing and scattering radiation, which means that water, of all things, is a pretty great shield. That's why some engineers suggest lining spacecraft walls with water tanks. It's like giving astronauts a spaceship made out of Gatorade bottles. But here's the twist. Water is heavy, and in spaceflight, every extra kilogram costs a fortune to launch. So while water shielding sounds great on paper, it's insanely expensive to actually pull off. Which is why researchers are also looking into something that sounds straight out of Star Trek: magnetic shields. The idea is to recreate Earth's invisible bubble, but on a smaller scale, around the spacecraft. Picture a mini force field that bends incoming particles away, just like Earth's magnetosphere does. In theory, it's genius. In practice, well, it's kind of like trying to carry around your own personal thunderstorm. Magnetic fields, that strong, take massive amounts of energy, and keeping them stable in space is no small task. But scientists are experimenting, and who knows? Maybe one day, we really will see spaceships surrounded by invisible force fields. Now let me ask you something. Have you ever seen those old cartoons, where a character hides under the bed during a storm? Funny thing is, astronauts might end up doing something kind of similar. On long missions, like trips to Mars, spacecraft might include a storm shelter. Basically, it's a small room in the middle of the ship, lined with extra shielding, where astronauts can cram themselves during solar storms. Imagine 4 or 5 astronauts, all stuffed into a closet-sized room, waiting for the storm to pass. Cozy, right? It sounds almost silly, but it could save lives. And that's not even the craziest idea. Some scientists suggest we might need to build habitats underground. Not on Earth, of course. We're talking Mars or the Moon. Both of those places have zero magnetic protection. If you're living on the surface, you're basically camping under a cosmic shooting gallery. So the solution: dig in. Lunar lava tubes, Martian caves, even artificial bunkers buried beneath layers of soil. Nature has already given us shelters. Giant caves carved by ancient lava flows. And honestly, doesn't that sound epic? Imagine astronauts living in underground Martian caves, like some futuristic version of the Flintstones. Except instead of dinosaurs, they're dodging deadly cosmic rays. But here's the part NASA doesn't talk about much. Even if we shield astronauts, even if we build caves or storm shelters, radiation still sneaks through. There's no perfect wall against it, which means the other battlefield is inside the body itself. And this is where it gets fascinating. Scientists are actually looking into medicines, pills or injections that could protect cells from radiation damage. Think of it like sunscreen, but for your DNA. One idea is antioxidants, the same stuff you hear about in blueberries or green tea, but supercharged. Antioxidants help mop up the chaos radiation causes inside cells. Another approach: drugs that trick your body into repairing DNA faster than normal. Imagine if your cells had a pit crew, like in Formula 1. Radiation comes in, wrecks the car, and your body swoops in to rebuild it before the damage spreads. It sounds wild, but it's being tested. And then, there's the boldest idea of them all: genetic engineering. What if, instead of trying to protect fragile human bodies, we actually upgraded them? Some creatures on Earth are ridiculously good at handling radiation. Tardigrades, those little microscopic water bears, can survive doses of radiation that would shred us to pieces. Cockroaches too, though that's less glamorous. Scientists are studying what makes these creatures so tough. And the question is, could we borrow some of their genetic tricks? Could future astronauts have enhanced DNA that makes them naturally resistant to radiation? Now, before you picture a Marvel superhero astronaut flying to Mars, this is all still speculative. But the fact that serious scientists are even entertaining this shows just how huge the problem really is. Now, let's zoom out for a second. Imagine you're one of those first astronauts heading to Mars. Your ship is lined with water tanks. You've got a storm shelter. maybe even some protective medicine in your pocket. Sounds doable, right? But here's the kicker. It's still not guaranteed, because radiation isn't steady. It's unpredictable. You might get lucky and hit a quiet period in solar activity, or you might find yourself in the middle of the worst storm in decades. And here's the scary truth. We don't actually know how bad it can get. The sun has cycles, sure, but it also throws tantrums that we've never witnessed during human spaceflight. If one of those megastorms hit during a Mars mission, the outcome could be catastrophic. And this brings us to a bigger question. Should we even be sending humans out there until we solve this? Or do we take the risk, knowing the dangers? Because exploration is in our DNA. It's a tough call, and it's one NASA doesn't like to dwell on publicly. They'd rather talk about shiny rockets and cool rovers than the possibility of astronauts getting sick years after returning home. But the truth matters, because those astronauts are people, real men and women with families, dreams, and futures. Here's something that really hit me. NASA actually limits how much radiation an astronaut can be exposed to over their career. Once they hit that cap, they're grounded. That's it. No more space flights. It's like their bodies have a radiation budget. And once it's spent, game over. And that budget, it's shockingly small when you realize how much is out there beyond Earth. Which means sending astronauts to Mars isn't just about surviving the trip. It might mean ending their space careers and possibly shortening their lives for the sake of exploration. But here's the twist, and it's a hopeful one. Every time we learn more about radiation, every experiment, every mission brings us closer to real solutions. And that's where the excitement comes in. Because maybe, just maybe, this invisible enemy is the exact challenge we need to force humanity to innovate in ways we never imagined. Just like crossing oceans once felt impossible, just like flying once felt like a fantasy, beating space radiation could be the hurdle that transforms us into a true spacefaring species. And speaking of transformation, what if I told you that understanding radiation isn't just about keeping astronauts safe? It's also teaching us about life itself, about aging, disease, even the limits of human survival. That's where part 3 comes in, because in the final stretch, we're going to talk about the emotional core of this story, the human side, the risks, the sacrifices, the inspiration, and how this invisible danger might actually hold the key to unlocking not just our future in space, but our health here on Earth too. So stick with me, because the best part of this journey is still ahead. So here we are, at the heart of it all. We've talked about what space radiation is, why it's terrifying, and the wild creative ways scientists are trying to protect us. But now comes the part that hits closest to home, the human side of the story. Because behind every spaceship blueprint, behind every radiation shield idea, there are people, astronauts, families, dreamers. And this invisible danger we've been talking about isn't just some abstract science problem. It's about lives, real lives. Picture this. You're an astronaut. You've trained for years, maybe decades. You've given up birthdays, weekends, even time with your kids, all for the chance to reach beyond Earth. You're strapped into your seat, the rocket shakes, the engines roar, and suddenly you're weightless. You're in space. But while the world is cheering you on, while millions are watching your journey, there's this invisible storm gnawing at your body, bit by bit, second by second. You can't see it, you can't feel it, but it's there. And you know that the longer you're out there, the higher the risk grows. That's not science fiction, that's reality. And this is what NASA doesn't usually spell out for the public. Astronauts are fully aware of the risks. They sign off on it, they accept it. But think about what that means. It's not just bravery, It's sacrifice. Some astronauts may come home healthy. Others may come home with health issues years later. Cancers, memory problems, maybe conditions we don't even fully understand yet. And yet they go anyway. Why? Because they believe the future of humanity is worth it. And maybe that's the real lesson here. Space radiation isn't just a scientific obstacle, it's a test of our values. How much risk are we willing to take? How much sacrifice are we willing to make for discovery, for progress, for the dream of becoming a multi-planet species? It's not an easy question. It's not meant to be, but it's one we all have to face together. Here's something most people don't know. NASA actually keeps detailed records of astronaut health for decades after their missions. They track them, study them, learn from them, because every astronaut's body becomes a living science experiment, teaching us how humans handle space. And some of those lessons aren't just for astronauts. They ripple down to us here on Earth. For example, research into how radiation damages DNA helps doctors understand cancer better. Studying how to protect the brain from radiation could one day lead to treatments for Alzheimer's or dementia. Even the antioxidant experiments I mentioned earlier. Those could spin off into new medicines for everyday people. So in a strange, beautiful way, astronauts aren't just risking themselves for exploration. They're helping all of us, down here, live healthier, longer lives. But here's the crazy part. As much as radiation seems like this unbeatable wall, history shows us that humans have a way of breaking through walls. There was a time when people thought crossing the ocean would mean sailing off the edge of the world. There was a time when flight seemed impossible, just a dream of mad inventors. And yet, we did it, again and again. Every barrier we've faced, we've turned into a stepping stone. Why? Because curiosity is in our DNA. Because we'd rather risk the unknown than stay forever in the safety of the familiar. And maybe that's what inspires me the most. Astronauts don't go to space because it's safe. They go because it's dangerous. Because it's unknown. Because someone has to be the first to take that step, even knowing the risks. And when they do, they carry all of us with them. Every time a rocket launches, it's not just a handful of astronauts leaving Earth. It's humanity itself, reaching out a little further, daring to dream a little bigger. Now think about the future. Imagine the first humans landing on Mars. Imagine them stepping out of their spacecraft, planting their boots in the red dust, looking up at a sky with 2 tiny moons instead of 1. That moment will be broadcast all over the world. People will cry, people will cheer, and what they won't see are the invisible rays pounding those astronauts every second. But those astronauts will know, and they'll stand there anyway, because in that moment, the risk will feel small compared to the achievement. And here's where I want to leave you with something powerful. Space radiation is scary. It's real. It's one of the toughest challenges we've ever faced. But it's also proof of how far we've come. The fact that we even have to worry about cosmic rays hitting astronauts on Mars means we've already accomplished something incredible. We've broken free of Earth. We've built machines that can carry us across the solar system. We've turned what was once impossible into a when, not if. And if history has shown us anything, it's that when always comes sooner than anyone expects. So maybe the real story isn't what NASA doesn't tell you about space radiation. Maybe the real story is what this danger tells us about ourselves. That we are fragile, yes. That we are vulnerable, yes. But we are also bold, relentless, curious. And that combination, the mix of weakness and courage, is what makes us truly human. So next time you look up at the night sky, I want you to remember this. Those twinkling stars aren't just faraway lights. They're destinations. They're challenges waiting to be faced. And radiation is just one more reminder that the universe doesn't give away its secrets easily. You have to earn them. You have to fight for them. And we will. Because at the end of the day, the human spirit is stronger than any cosmic storm. If this story moved you even a little bit, if it made you think differently about space, about risk, about the future, then I'd love for you to join this journey with me. Hit that like button. Drop a comment sharing what you think humanity's biggest challenge in space really is. And don't forget to subscribe so you don't miss the next deep dive into the mysteries of the universe. Together we can keep the conversation going, keep the curiosity alive, and maybe, just maybe, inspire the next astronaut who will one day walk on Mars. Because the universe is waiting, and it's not going to wait forever.